Hello, my lovely viewers and my dear students. Welcome to another session of my math distance learning class. So today's topic is in continuation with the last video which was put on chain rule. In today's session, we are going to be learning a very important topic of differentiation, which is called implicit differentiation. So let's get started. Okay, now, so let's acquaint ourselves with the learning objectives for today's class. In today's session, you will be learning how to identify implicit functions and then to calculate the derivative of implicitly defined functions. Now, this topic that we are going to be covering in today's session is very important and useful topic for grade 11 and 12. So let's get started with this important topic. And before we move on to today's session, I would like you to recall from the last video about the various rules for differentiation. I hope that you have learned all these important rules like the constant rule, the power rule, the product rule, the quotient rule and the chain rule that we had covered in the last video. I will put the link in the description box. I would urge you to first watch that video if you haven't still, and then come on to this video for better understanding. Okay, so let's now try and understand this important concept of implicit differentiation. I'm putting on the screen these two equations. I want you to observe what is common in these two equations. Okay, so if you observe in the equation y equal to 3x minus 5, one variable y is expressed clearly in terms of the other variable x. So in this equation, your y is said to be explicitly defined in terms of x. So such is an example of explicit function or explicit equation. Similarly, the second one is also explicitly defined function. But in this lesson, we are going to be focusing on implicit function. So let's understand what is the difference between the two. So if I'm able to write y is equal to 1 over x, then clearly y is in terms of x as defined 1 over x. So this is an explicit function. Now, if I rewrite this function, I cross multiply and then I put it in this form, xy equal to 1. Now I can say that this function becomes implicitly defined and y is now defined implicitly in terms of x. So I hope with this example, it is clear to you what is the difference between the two types of functions, explicit and implicit. Now, it is quite easy to derive or to take the derivation of an explicit function. So now in this lesson, we are going to be focusing in implicit functions and how we are going to differentiate that. So let's begin with this example, x plus 4y cubed plus 3y square plus y equal to 5. And here looking at the function, I'm sure all of you are able to understand that this is an example of an implicit function. As your both x and y are together, one is not expressed clearly in terms of other, and that's why it is an implicit function. Let's take an example here, students. I hope you can easily understand that this equation x square plus y square equal to 1 is the equation of a circle. So let's try and find its slope, that is dy by dx. So because it is an implicitly defined function, if we are able to find the slope, it means we have to find dy by dx. So let's do implicit derivation of this function. So the step one that we are going to be following is to differentiate this equation. So let me name it as number 1. Let's differentiate both sides of this equation with respect to x. So when we do that, x square is in terms of a power. So definitely we go for power rule here. And for the second part, d by dx of y square, we'll be going for chain rule. And I hope that you are able to understand why we are using chain rule here. Think about it. The reason is that because we are differentiating with respect to variable x and the function is given with respect to y. So that's why we have to go for the chain rule. And then finally on the right side, we are just differentiating with respect to a constant. So that is going to be eventually 0. So we use the chain rule. Please note how we have used it. So it was y squared. So we do the power rule first, 2y, and then dy by dx. On the right, we have got a 0 since the derivative of a constant is going to be 0. And now you can just simplify and extract out your value of dy by dx. So just rearrange this a little bit, simplify, and then you will be able to write your dy by dx as negative 2x over 2y. Now we are going to cancel the common factor and eventually reach to our final answer, that is dy by dx is equal to negative x over y. This is our final answer. We have reached to the slope of this function. So what you saw, the steps here, this is called as your technique of implicit differentiation. Let's take one more example here. 2y equal to x square plus sine y. Again, it is an implicit function. So let's follow the same steps. Let's differentiate both sides with respect to x. On the left, you get d by dx of 2y. So you are going to do the derivative with respect to y. On the right, you have x square plus sine y. So let's do the differentiation of individual terms. So d by dx of x square, you do the power rule here. And d by dx of sine y, so you apply the trigonometric derivative. And if you have watched my last video where I gave you the recall of all the important rules, you will be easy to understand that we have to do the derivative and it will come out to be as cos y dy by dx. So this is going to be the next step. We simplify it further, collect the terms of dy by dx. So dy by dx is here also, dy by dx is here also. Let's collect it, factor, take the common terms, and then both sides we can divide by 2 minus cos y to get our value of dy by dx. This technique, what we have applied in the previous question, and this one is called implicit differentiation. Let's summarize the two steps. First, we differentiated both sides with respect to x, and then we solved for dy by dx by taking common terms. I hope the technique is clear to you. We'll be taking more questions in the slides to come to make this concept more understandable to all my viewers. Okay, so let's take one more example. This one is f of xy. The function is given to you an implicit function xy whole square. And you can easily understand that because x and y square are multiplied to each other, that's why it is an implicitly defined function. So let's go ahead and apply a technique that we have learned for implicit differentiation. Step 1, we take the derivative of both sides with respect to x. So we are going to be getting this step. Now on the right, the function is x multiplied with y square. So definitely you have to go for product rule to get the derivative. And then for the next step, we do the chain rule because we are differentiating d by dx with respect to x and the variable which is inside is different, that is y square. So first we do the power rule to get 2y and then dy by dx. So we have applied chain rule here, and in case you have forgotten the chain rule or you want to have a revision of that, then I would advise you to watch my previous video. The link will be there in the description box to review and recall your chain rule to find the derivative. Now we just simplify and reach to our answer. So this is the implicit differentiation complete, which gives us the final answer. Okay, now let's recall some guidelines for implicit differentiation. In the previous examples that we have seen in the slides, we have seen some steps that we have followed to reach to our answer when we are doing implicit differentiation. So I would want you to remember these rules, students, so that you can easily reach to your answer without committing any errors. So step 1, differentiate both sides of the equation with respect to x. Step 2, collect all terms involving dy by dx on left side of the equation and move all other terms to the right side of the equation. So the direction is not important, but it's just that you need to isolate on one side all the terms which are having dy by dx so that you could factor them out in the next step and then solve for dy by dx. So that's your step 3 and 4, to factor dy by dx on left side or any one side of the equation, keeping everything else on the other side, and then to solve for dy by dx. Please remember these steps so that you could use them easily without making any mistake and reach to your correct answer. Very helpful for your examinations. Okay then, next, now that you have understood all the steps you need to follow, let's apply those steps in this example. So find dy by dx given that y cube plus y square minus 5y minus x square is equal to negative 4. So again, this is an implicitly defined function. Let's do step 1, which is to differentiate both sides of the equation with respect to x. And when you do that, very easily you can see that on the right, you are going to be getting the derivative of a constant number, negative 4, which will be eventually 0. On the left, you take the derivative of each of the individual terms in this polynomial and then apply the power rule or the chain rule or the constant rule, whatever is relevant as per what is given. So in the first part, dy by dx, dy cube by dx, you have to apply the chain rule. And I'm quite confident by now you are understanding how we are deciding on the rules here, because the differentiation is happening with respect to x and the variable which we are differentiating is different, that is y cube. That's why we are going for chain rule. Similarly, we'll go for chain rule for the second term because the same reason, and the third one also has the same reason. It's just that 5 being a constant would come out of the derivative. Next you have d by dx of x square. So you are going to be just going for the power rule directly to get negative 2x. So that completes the first step of our implicit differentiation. Okay, then let's move to step 2. Here we are going to be collecting all the terms which have dy by dx on the left side and move all other terms to the right side. So from the last slide, you saw that there are 3 terms having dy by dx. So let's collect them on the left side and we are moving the negative 2x on the right, making it plus 2x. Step 3, we factor dy by dx. So whatever is common, we are taking it in brackets and that gives us a polynomial 3y square plus 2y minus 5. And last step, we are going to divide by this common factor, this polynomial, to get our dy by dx. So this is your final answer, which completes your implicit differentiation. I hope with so many examples, the concept of implicit differentiation is now crystal clear to you. Still, if you have any queries or suggestions, I would want you to type them in the comment section below and I will help you out. Now it's time for me to check your understanding. So I would want you to try and solve these 2 questions yourself and then to type your answers in the comment section so that I can check your understanding. The first question is definitely on implicit differentiation. So you will solve it using the 4 guidelines, the 4 steps I have explained, and you will solve it stepwise with all the working. Question 2 is a multiple choice, so you just have to give me A, B, C, D, what is the correct answer. And let me give you a hint for question 2. This question too is based on chain rule. So again, I would highly appreciate if you watch the previous video and this video, both of them, and then you go for these questions. So that brings us to the end of today's session, which was very, very important for grade 11 and 12. So thank you so much, my dear viewers and students, for joining my channel, for liking, sharing, and subscribing. Also, keep doing that for watching more and more of my math videos. That is a good motivation for me. And let me know what other topics you want for mathematics videos that would help you. That's all from my side. Thank you and bye, students.